So step 1 in factoring is look for the greatest common factor, or the GCF. So in example 1, a cubed plus 2a squared minus 5a. Henry, what would be the GCF? What could I pull out of all three of those terms? A. So we're going to pull out the a, and I would get a squared plus 2a minus 5. Okay, it's not going to do anything more than that, but that's what I would pull out. So Hannah, in example 2, what would the GCF be of 12x plus 42xy? What could I pull out of both of those? 12x. Okay, there's definitely an x, and 12 is a good try, but 12 times 4 is 48, so something a little bit smaller than 12. Yeah, it's 6. Thank you, Henry. Yep. So that's 2 plus 7y, and what you're doing is you're using the distributive property, and we want to check our work. 6x times 2 is 12x. 6x times 7y is 42xy. Okay? So step 1 in factoring, look for the GCF. Step 2 in factoring is to count the number of terms. So the first thing we're going to look at is a difference of two perfect squares. So it's a squared minus b squared factors into a plus b times a minus b. So in example 3, McKenna, if I have y squared minus 6, y squared minus 16, how does that one factor?
Y plus 4 and y minus 4.
Good. And you guys, check your work when you factor. Y times y is y squared. The outer is minus 4y and the inner is plus 4y. They cancel. 4 times minus 4 is negative 16. Now let me ask you this question, because a student will typically ask this. What if you wrote y minus 4 down first times y plus 4? Is that wrong? What if I have these switched?
No.
It would be okay, right? Because we're really saying a times b is the same thing as b times a. Do you guys remember what property is that? Commutative property. That's the commutative property that says you can switch the order. All right, let's look at example 4. Andrew, if I want to do 25m squared minus 36, how would that factor? Okay, Jaslyn, can you help?
Fm plus 6 multiplied by fm minus 6.
What are you saying? F?
I mean 5.
Okay,
sorry.
Mike, what's
sorry.
F?
Sorry.
No, okay. I thought, what? You're doing a different problem than I am. Okay. No, that's fine. Okay, 5m plus 6, probably from 5 is an F. Yeah, I know. I was like, okay, 5m plus 6 times 5m minus 6. So, Andrew, what we're doing is we're finding the square root. Okay? So, 5m times 5m gives you 25m squared. 6 times 6 is your 36. Okay? All right. Carmel, do you want to try example 5? X to the 4th minus 16.
Is it x squared plus 4 times x squared minus 4?
Excellent. Good job. Okay. X squared plus 4 times x squared minus 4. Now, I want you to look at the blue paper. And under two terms, do you see anywhere a squared plus b squared as one of the options? A squared plus b squared. No, it's not there. So, and I'm going to explain why in example 6. But x squared plus 4 isn't going to factor. But x squared minus 4, hey, wait a minute. That's a difference of two squares again. So that's going to keep going, x plus 2, x minus 2. Do you see that? So it is your responsibility to look to see if it will continue to factor. All right, so now let's look at example 6, z squared plus 9. So, Elena, what do you think we might be able to try to factor that one?
Well, mine's a perfect, like, it's a perfect square.
Yeah.
And z squared is a perfect square.
Right. So, how about trying z plus 3, z plus 3? Let's try that. And then you would FOIL to see if it works. That's z squared, that's 3z plus 3z is 6z. Alright, that doesn't work. What about, okay, we know that if we have a plus and a minus, that'll make the outer inner cancel, right? But what happens with the last? It's a minus 9. Okay, that didn't work. How about we make them both minuses?
No, because I'll be negative 6z.
Yeah, you're right. In the middle, we're going to have a minus 6z. Now, there's no other options. I mean, I guess I could try a 1 and a 9, but that's going to add up to 10z if I did that. And I really mentioned it here on example 5, is that when you have a sum of two perfect squares, the reason why it's not on my blue factoring sheet is that it does not factor. And what we're going to do is we're going to write capital D, capital N, capital F. Does not factor. Do not say no solution, because this was not an equation, so that doesn't make any sense to put the no solution symbol. The other thing is, if you would like to use some higher level mathematics, in upper level mathematics we say that it's prime. It's a prime polynomial, okay? But DNF does not factor is absolutely fine. Alright, perfect square trinomials. A squared plus 2ab plus b squared equals it factors into a plus b squared. A squared minus 2ab plus b squared equals the quantity a minus b squared. So before we start these, let me back it up a little bit. And if you recall, if we had 2x plus 3, the quantity squared, we know that's 2x plus 3 times 2x plus 3. And you know that's 4x squared plus 6x plus 6x plus 9. So that's 4x squared plus 12x plus 9. Okay, so I'm going in the reverse where I'm multiplying it out because I'm trying to bring it back as to how it works in the backwards direction. So if I take 2x plus 3 times 2x plus 3, do you see that I have 2 of the 2x times the 3? That's where the 2 is coming from, okay? Now watch this. So what I can do, and see, and I use this, I feel like I'm a little cheater as I do stuff because I know all the shortcuts. And I know how to factor in reverse, so I know how this works. So what you can do without doing these two lines, I could take 2x and square it. I can take 3 and square it. And then you can take 2x times 3, which is 6x, and double it. Not square it, but double it. So watch this, okay? If I have 3x plus 5, the quantity squared, watch how I can do this with no work. That's 3x is being squared. You can take 3x times 5 is 15x and double it. That's 30x and then 5 squared. You see that? Let's do one more. If I have 2x and let's make it a minus 7. If I have 2x minus 7, 2x being squared is 4x squared. You take 2x times 7, which is 14x, and double it. But because there's a minus, it's minus 28x. And then 7 squared is 49. Do you see how fast that is? So it's like, that's how I do them. I don't write them out and do all the, why do all the extra work? So now, in example 7, if I want to factor h squared plus 6h plus 9, here's how I do it. You have to check. This is h being squared. This one's 3 being squared. And then to get the middle, is it 2 times that h times the 3? Here's the h, there's the 3, and you double it. Yes, that works, right? So this factors into h plus 3, the quantity squared. Let's do example 8. This is n being squared. This is 6 being squared. Is the middle term 2 times n times 6? Yes. Now it's a minus, so it's n minus 6, the quantity squared. Okay? All right, let's try 9. What is being squared to give you 4s squared?
2s.
Awesome, guys. 2s. And then that's just t. So then you take 2 times the 2s times the t. That's 4st. That's what's in the middle. So it's 2s plus t, the quantity squared. Now, as I've been moving through this, I've been just trying to practice that particular type of factoring. But look at your blue papers, and what is step 1 in factoring? Always look for a GCF. So I don't want you to think I wasn't doing it. Our focus was difference of two squares, perfect square trinomials. Now, you need to remember, always, step 1, look for the GCF. There is a 2 in common. So you're going to pull it out. So I get 2 times the quantity, y squared minus 10y plus 25. Now, I need to see, is this a perfect square trinomial? Well, that's y being squared. This is 5 being squared. Is the middle term 2 times y times 5? Yes. So this is, and don't lose that GCF. It's 2 times the quantity, y minus 5 squared. Okay? All right, x squared plus bx plus c. This is not a typo. There is no number in front of x squared except a 1. So when you have this, what you're going to do is you do want to see, is it a perfect square trinomial? Well, I can tell very quickly it's not, because this is 3 is not a perfect square. So what you do with these, please check for a perfect square trinomial, otherwise it'll make your life real difficult when you're trying to work with some of those. You're asking yourself now, when there's a 1 in front of x squared, what two numbers multiply to positive 3 but add up to positive 4? Carmel?
3 and 1.
3 and 1. Now remember what I told you. Check your work when you factor. X times x is x squared. The outer is 1x, the inner is 3x. That adds up to 4x. 1 times 3 is 3. It does not matter. Remember, we already talked about this. If you put your x plus 1 times x plus 3, that's okay. All right, number 12. It's not a perfect square trinomial. Now you're looking for two numbers that multiply to positive 14, but add up to negative 9. Noah, what do you think?
-7 and -2.
Good job. And check your work when you factor. Now something I need to point out to you, if the product is positive, they're either both pluses or both minuses, right? If it ends in a plus, they're the same sign. All right, now let's try this one because it looks like we're really getting this. What two numbers multiply to 44 but add up to 15? Carmel?
4 and 11.
Good. 4 and 11. And that does check. All right, example 14. X squared plus 5x plus 2. Okay, well there's a problem here, right? Because the only two numbers that multiply to 2 are 2 and 1, and there's no way they're going to add to 5. So what should we write down? Does not factor. D and F. Okay? So don't forget about that. All right, now, in example 15 and 16, I need you to write a note here. When the leading coefficient is negative, you must factor out the negative sign. This is very, very important for example 15 and example 16, and it'll just, otherwise it is so confusing to do this. So when your leading coefficient is negative, you must factor out the negative sign. So in example 15, watch what this does for me. If I factor out the negative, I have the quantity x squared. Notice it's a minus 16x and a plus 28. The signs flip. So now I'm looking for, it's definitely not a perfect square trinomial. What two numbers multiply to positive 28 but add up to negative 16? 2 and 14, but are they both pluses, both minuses, or one of each? They're both minuses, so minus 2, minus 14.
You're 12. Oh, no, sorry.
It's 14, right? Okay. All right, now try this with example 16. You might need your calculator. Yeah, the two numbers that multiply to negative 180, so you're going to have to try some factors there. And I apologize if I move on too quickly and you were still trying, because factoring is one of those concepts that some people get it, they just see it and they get it. And others of us, it takes a while. So the good news is on homework or on quizzes, you know, you can take your time through it, but maybe you need to watch this video and pause it and let yourself try to find them if I'm moving too fast. All right, did anybody get it yet?
I got 1. Oh, wait. Yeah,
Remember to check your work
I have
when you
it.
factor.
I forgot to factor. I have it.
What is it?
It's 6 and negative 6 and 30.
It's positive 6
Yeah.
minus 30. There you go.
There.
Okay, and you guys would have eventually gotten it. Here's the process I try. I do 1 and 180, 2, 90, 3, 60. You know, I mean, I go through every number that'll go in. It just takes a while. Okay, now solving equations. I want to point out that up to 16, we were just working with expressions. And so what happens sometimes is students get this all jumbled in their minds. And an easy way to straighten it out is if it's an equation, you're going to get a solution. If it didn't start as an equation, then you can't get an x equals, okay? It's just an expression. So let's review something from Algebra 1 called the zero factor property. And here's what the zero factor property says. If you have a times b equals 0, then either a was 0 or b had to be 0. And this is the property we're going to use here. Again, the zero factor property, if a times b equals 0, and it has to be equal to 0, it can't be equal to 2 or 1 or something like that, then a is 0 or b is 0. So look at example 17. If I have x squared minus 5x minus 36 equals 0, okay, I have it equal to 0, but I don't have it factored. A times b implies that it's factored. So it's not a perfect square trinomial. Now, even though that 36 is squared, is 6 squared, do you see that x times 6 doubled would be 12x? So it's not a perfect square trinomial. So what two numbers multiply to negative 36, but when you add them, you get a negative 5? Noah?
9 and negative 4. I mean, negative 9 and 4.
Negative 9 and a
Switch them up.
positive 4. All right, check your work when you factor. And then what you're going to want to do is set each factor. This is what the zero factor property says. Set each factor equal to 0. So x minus 9 equals 0 or x plus 4 equals 0. And then I know how to solve those. So x is 9 or x is negative 4. Okay? All right, let's try 18. X squared squared minus x minus 42 equals 0. In order to solve this, we need 0 on one side, which we have. It's definitely not a perfect square trinomial. So then I'm trying to think of two numbers that multiply to negative 42, but add up to negative 1. Elena?
Negative 7 plus 6.
Good job. Now, here's a common mistake on this one. I'll see an x plus 7 and an x minus 6. And when a student does that, that tells me as the teacher they didn't check it. Because if you had done a quick check, that would give you a plus 1x. And so that's not a major problem, but if you check it, then you just switch your signs. Do you see that? Like, there's helpful strategies. Now, if you're comfortable, if you can tell the factors are always going to give you the opposite answer, then you can do that and skip that extra line. If that's too much for you, keep your work in there. All right, now, in example 19, I do not have this equal to 0. So the first thing you have to do is multiply out the left side to get x squared plus x, and you have to subtract the 72. So I get x squared plus x minus 72 equals 0. So that's definitely not a perfect square trinomial. I'm looking for two numbers that multiply to negative 72, but add up to a positive 1. Noah?
Positive 9 and negative 8.
Good. So x is negative 9 or x is 8. Okay? All right, does that make sense? Good. All right, now, in example 20, it says find the zeros of the function by rewriting in intercept form. Intercept form is another way to ask you to factor, okay? And something I need to point out to you is zeros are the x-intercept of a graph. Okay, zeros are the x-intercept of a graph. And what do we know about an x-intercept? We know that y is 0, right? And an x-intercept is on the x-axis, so you're not up or down anywhere. So what you're actually doing is you're changing y equal to 0 because that's how you find a 0. And then intercept form means it's factored. So what two numbers, Carmel, multiply to negative 12 but add up to negative 1?
Negative 4 and positive 3.
Good job. So this is x equals 4 or x equals negative 3. Now what I want you to do is I want you to take out your graphing calculators, and I want us to go graph this in our y screen so you can take a look at this and see and make a connection graphically. So go to your y screen, and in y1 we're going to enter x squared minus x minus 12. Do zoom 6 if you can't remember what your window looked like. And we do know graphically this is a parabola that's opening up. So even though on this window I don't see the very bottom, I don't see that minimum, it doesn't really matter here. But do you see here's an x-intercept at x is negative 3 and at x is 4. So the zeros are the x-intercept. That's really, really important for us to make that connection. Okay? All right, let's try letter B. I'm going to set y equal to 0. Now don't forget this, and I'll tell you, this is one of the most common mistakes I see students make, is they forget about the perfect square trinomial. This is, you got to try it. X is being squared, 6 is being squared, 2 times x times 6, ding, 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 I've got a winner here. This is x plus 6, the quantity squared. Now, that's also like x plus 6 times x plus 6, right? You're not going to write it down twice. This does mean something else graphically, and we just covered this in pre-calculus yesterday. When you have an even exponent, the graph bounces off. That means, let's go graph this one real quick. If I put x squared plus 12x plus 36, at x is negative 6, one of your zeros is there twice, it's gonna bounce off. It's really kind of cool. So just planting some pre-calculus seeds. All right, let's try the last one. 0 equals. Can you think of two numbers that multiply to negative 30 but add up to negative 7? Carmel?
Negative 10 and 3.
Okay. So then my two zeros are x is 10 or x is negative 3. But do you realize that we did write it in intercept form? That's this multiplied part out. Okay?